breakdown of what trigonometry is all about. So for example, if you're in grade 12, right, when it comes to trigonometry, this is what you need to know. The first thing is obviously trig ratios. You see, you need to know trig ratios. So trig ratios refers to SOHCAHTOA. SOHCAHTOA. So this is referring to, for example, the S here, O and H, refers to sine, of which the ratio for sine is opposite over hypotenuse. And then the CA refers to cos, and the ratio for cos is adjacent over hypotenuse. Lastly, you have the TOA, TOA. This is referring to tan, of which the ratio for tan is opposite over adjacent. Now, with all these three, right, the idea is you would be working with a right-angled triangle. In this right-angled triangle, you have an angle there, and then depending on where this is, right, this will be the opposite, this will be the hypotenuse. The hypotenuse is always the one opposite the 90-degree angle. You see, the longest one. And then the adjacent is the one directly next to your angle. So in this image, your different, the way this works is you basically have 3 points to put something. You will either be working out an angle, you will either be working out one side, or you'll either be working out another side. So obviously the idea is there's 3 things here. If you want to work out one of them, you at least need to have 2 pieces of information, meaning if you want to work out the angle, you need these 2 pieces of information. If you want to work out, for example, the O, you need these 2. If you need the H, you need those 2, which is how all formulas work. All formulas require you to work out something specific if you at least have everything else. You see, so that's the basics of trigonometry, the trig ratios that we know. Now, obviously, these trig ratios are limited to just right-angled triangles only. You see, if your triangle is not a right-angled triangle, then you cannot use the trig ratios, you see. So in a situation where you don't have trig ratios, in a situation where you don't have right-angled triangles, you see, let's say here all triangles, all triangles. In a situation where you have all kinds of triangles, including right-angled triangles, in that kind of a situation, formulas that will help you work stuff out, because remember, these formulas help you work out, an angle or different sides. So if you have, let's say, a triangle that's like a random triangle, let's say something like this, you see, a triangle like this is not a right angle triangle. It can be anything. So let's say this is labeled A, B, and C. With a triangle like this, what we normally do is, if your triangle has no actual values, we refer to, for example, this angle here, we can refer to this angle as B, right? But then its opposite side, we refer to it as like small b. And then for something like C, if this is angle C, its opposite side, we refer to this as like small c. If this is A, we refer to this side as like small a. So with this being written out, right, we are able to lay out 2 formulas that are actually on your formula sheet. These formulas are not necessarily on your formula sheet, but they are formulas that you need to know. But they're easy, these are like the basics of all trigonometry. So with a triangle like this one, right, you have 2 formulas that you can use to work out different sides and different lengths. The first one is what we refer to as the sine rule. Now, the sine rule looks as follows. It basically says a side over sine the angle will always be equal to another side over sine the angle, or it will be equal to a side over sine the angle. Now, the idea is you only use 2 of these at a time, So if you look at your triangle, in practice, right, what you need is at least one side and its opposite angle. As long as you have a complete side where the value is given and the angle where the value is given. In that kind of a situation, right, you'll, for example, have all this information, something to put over there and something to put over there. Now, for you to ever need to use the sine rule, it will be a scenario where you at least have these two given, but then let's say this one will be given, right? But then its opposite angle will like be missing. Let me put it this way. Say you have this angle, right, given, and this side given. That's fine. You may have this side given, but then they may be asking for the angle C over there. Because remember, with these three laid out, you're only going to use two of them at a time. So you're probably maybe going to use these two together. So if you're going to use this formula to work out something, you will obviously need at least 3 pieces of information of the 4. Because here there is A and A, and this is the side, this is an angle, this is a side, this is an angle. So you can see it's a total of 4 pieces of information that can be put in here. So for you to ever consider using this formula, you at least need 3 of the 4 pieces of information. If you have these 3 here, you would be looking for B. If you have these 3 here, you would be looking for the side A. You see, going on and on and on. It all depends on which 3 pieces of information you have, because the 4th one is what you'll be looking for. That's the sine rule, you see, and this sine rule refers to all kinds of triangles. You can use the sine rule. So with in addition to this sine rule, right, you have something called the cosine rule. You see, the cosine rule, again, you will be working with a triangle, any kind of triangle, even a right angle triangle, it doesn't matter. So the cosine rule, the formula is also on your formula sheet, and it looks as follows. You see, it's something that you don't necessarily have to cram because it's on your formula sheet. It says a squared is equal to b squared minus, plus c squared, right? And then it is minus 2bc and then cos A. This is on your formula sheet. Before I even carry on, right, let me open up the formula sheet here, so that if you're looking nicely, right, at this formula sheet, what we have already spoken about is the sine rule. You see, this is saying in a triangle where it's a triangle that has angles A, B, and C. You have a formula here that can help you work out different sides or different angles. You see, 2 of these at a time. Now, what we have just showcased here is another formula, right? Where this formula, again, it all depends on the kind of information you're given and what it is that you're looking for, you see. But before we get too deep into that formula, this one that we have just mentioned here, right? The one thing you can also remember is that it can actually also be written the other way around, where the angles will be on top and the sides will be at the bottom. You see, meaning this same formula here, you can write it with, let's say, A, sine A at the top with A at the bottom, sine B at the top, B at the bottom, sine C at the top, and then C at the bottom. You see, so normally if you're working out an angle, you might want to have the angles on top. If you're working out a side, you might want to have the sides on top. You know, it just makes it easier for you to simplify. But whichever way you do it, you will always get a correct answer. So the reason we're also looking through these different formulas and all that is, I'm trying to give you the idea that with trigonometry, right, your theory is king, you know. So in as much as this is a formula, you can, just by us going through this, you can see this is not necessarily how a person learns something, you know. This is more of like a scenario where you're just seeing the formulas, you see, but you can't necessarily say this is how a person learns. You see, this is almost like putting you in a position where once you start to learn it by actually like reading through the questions in your textbook, it'll make better sense because you would have seen it before, you see. So moving on to more information on trigonometry. So with all this being said, right, with trigonometry, it then has different, it has like a bunch of stuff. You see here, we're just talking about triangles and like solving triangles. But with your trigonometry information that you need to know, you have many different kinds of formulas that deal with many different kinds of things, you know. For example, you have something that we refer to as the reduction formula. So all we're talking about here is basically formulas that formulae. It's formulas that are basically used to work stuff out, break stuff up, simplify stuff, solve stuff. The reduction formulae, it's obviously something we cannot even dive into now, you see, because it's just going to seem a bit too vague, you see. But then the reduction formula allows you to like have an expression, and that expression you are able to break it down into something smaller. This is an example of a reduction formula, one of the formulas in the reduction formula. So these kinds of formulas, right, what they do is they basically allow you to break down different trigonometry expressions. Because with trigonometry, one thing you'll notice, right, for example, when you will go through the trigonometry course, there's like 5 chapters, you see. Chapter 1, let me just put it this way, chapter 1, 2, 3, 4, 5, you see. So in something like chapter 1, you will have questions like proving identities, proving identities. In something like chapter 2, you will have questions like what kind of questions are in chapter 2? I think you have what you call general solutions. General solutions. And then in something like chapter 3, you have trig diagrams. So in with trig diagrams, that's where you basically that's how you basically make use of, you know, things like the trig ratios and all that. And then something like chapter 4, you have trig graphs. Trig graphs, that's basically the graphs of sine, cos, and tan. Because in as much as these are like trig ratios, sine, cos, and tan are actually also actual graphs. Chapter 5 then has 2D and 3D triangles. 3D triangles, you see, of which with 2D and 3D triangles, those are the ones that deal with basically these 2 sets of formulas that we have spoken about, you see. SOHCAHTOA, sine rule, and the cosine rule. You basically mainly use that for 3D triangles. So for something like these other topics here, literally everything else, where you have like trig diagrams, general solution, and proving trig identities. In these topics here, you are going to make use of things like the following. You see, you're going to make use of virtually almost everything, you know. You're going to make use of things like the reduction formula, let me just write it down here. Reduction formulae. You're going to make use of things like double angles, and then you're going to make use of things like compound angles. And then if I can keep adding to this, right, you're definitely going to make use of let me try and think a bit more. The best way to try and think about it is actually to just refer to the formula sheet, because the formula sheet, if you look downwards, it's all trigonometry. See here, trig graphs and all that. Things like the area rule is this formula here. The area rule is actually something I should have mentioned before even talking about the reduction formula, because the area rule basically also works with any kind of a triangle. Because remember, when it comes to triangles, what we are used to is things like we are used to what you may call, what are we used to again? We are used to, for example, half base times height. That's basically the only area formula we know, you see. But then when it comes to trigonometry now, you need to know another formula for the area of a triangle. And that formula says the area of a triangle will always be a half multiplied by one side, multiplied by another side, multiplied by sine a specific angle. So the idea with this formula is it specifically works where the triangle here will have A, B, and C as the sides. So remember, we specifically said, right, if this is A, right, this side will be labeled A. If this is B, this side will be labeled B. If this is C, this side will be labeled C. So for you to use the sine, the area rule, you specifically need to have this angle here, and then you need to have the side here and the side there. It has to be specifically these two sides. It cannot be, you know, you could have this side, yes, but what I'm trying to say is for you to use this specific formula, the information that is needed is a side here, a side there, and an angle over there. You know, that like forms the area rule. So you can see that when it comes to trigonometry, right, it's actually quite a lot of stuff. When you're looking at it from like a bird's eye view, it's a lot. But the thing is, it's almost like having a bunch of tools, but then not all tools are used to do the same job, you know? Because if you just look at these formulas here, all these here, from this line, from these going down here, all these are dealing with trigonometry, you see? So the thing with trigonometry is it's almost like, as I said, having like a toolbox. And this toolbox has a lot of tools. You know, there's a tool used for this, there's a tool used for that. Now, you just want to know what tools do you have and what are those tools used for. You see, that's the idea with trigonometry. Now, in terms of you learning all these different tools that you need, you are obviously going to need to do the following. So the first thing that I definitely recommend is this is something you can actually do simultaneously, right? You could be going through the trigonometry playlists while reading through your study guide, because in the Math Simplified study guide, you are definitely going to what you may call, you're basically going to get a nicely broken down way of just taking everything in bit by bit. It's more like a proper roadmap where you'll start with one topic, then you'll move on to another one, going on and on and on. Why is YouTube not loading now? Like, since when? You know, since when does youtube.com not want to work? You know, it's quite it's quite weird, but I think for now you get the idea. You know, that's basically trigonometry in a nutshell. You know, obviously there's the trig graphs, as we said here. You know, trig graphs, you're going to have to know different laws and different pieces of information about trig graphs. With 3D triangles, we mentioned it's just basically going to be these formulas that you need to know for that. And then proving identities, getting general solutions, and working with trig diagrams, it's also going to be the same set of formulas. You see, reduction formulae, double angles, and compound angles.